Hello. Hi, as Dave mentioned, I have the opportunity to own our data center and our cloud business. We moved our security components, all of our signatures and all of our capability into a cloud-based architecture a very, very long time ago, about 8 years ago. As we moved into that architecture, we really came across a lot of new concerns that we had not seen from an infrastructure perspective in how we ran our company. And as a result, we said, wow, this is going to create a lot of challenges for anybody who's using cloud architecture. And so we started a cloud division. So we originally did security from the cloud about 8 years ago. And in a matter of 2 or 3 years, we very quickly realized we need to do security for the cloud. And so about 4.5 years ago, we started a cloud division. As Dave mentioned, I had the opportunity to start that up. Since then, we've invested several $100 million. I have a couple hundred dedicated full-time engineers just looking at how does cloud architecture and cloud infrastructure evolution change security? How does security enable cloud? And so I want to be clear, our goal in our division is not to put the brakes on the car to slow it down. So do you put brakes on a car so the car can go faster or slower? Faster, right? Brakes were invented so the car could go faster, right? So our job is to enable you to move to the cloud. So we look at security as an enabling technology, not as a roadblock or a brake to make you move slower. And so I want to talk really today just about that 4-year journey, what we've seen enterprises and government organizations as well as carrier providers encounter as they've moved through these technologies. So I'm not really going to talk about products. I'm not going to give you a big trend pitch. I'm really just going to talk about what we've seen as the cloud has evolved and what security challenges have presented themselves. Okay, so first of all, if you look at security strategy for most organizations, for 20 years, it's been something we call outside in. And the goal is to rack and stack all of the security on the edge, build as big a fortress as possible, and try to stop everything as it comes in. Trend Micro obviously has been a leader here on some of the edge technologies around email, web, security. So we've been part of this business for 20 years. And it really is, if you look at organizations, most of them have less and less security the further you go into the data center or the internal network environment. The security posture and profile and investment decreases. I want to talk a lot today about, given all the new threats, this model is insufficient for dealing in a cloud architecture. I'm just going to highlight 3 reasons. There's many. The big ones I'll talk about today are advanced persistent threats. The nature of the threat has changed to render this model less effective. The second one is mobility. We have a bunch of breakout sessions today on mobility, so I won't spend a whole lot of time on this stage about that. Hopefully it's obvious why mobility is breaking down this external perimeter-based security model. And then I'll talk a lot today about elastic perimeter. So this is really the essential concept of being able to move workloads across data centers into public cloud, into private cloud arena. And the nature of that has really changed how security needs to be provided. So all of these threats, all of these changes in architecture enable security breaches to pass that perimeter quite easily. And so the threat landscape of cloud-era security has really rendered outside-in or perimeter defense less effective than it used to be. So let me give you some good examples. So today I'm going to talk about the journey to the cloud. It's literally, we call it just 3 steps, physical to virtual to cloud. Is virtualization part of cloud computing? We think absolutely so. So theoretically, you can do cloud computing on bare metal. 99.99999% of organizations use virtualization as a step to go into that. So I'm going to talk a lot about virtualization. I'll call physical to virtual phase 1 in the journey of the cloud, and then virtual to cloud, both private and public or some form of hybrid cloud, will be phase 2. So let me talk to you about what we've seen at customer sites, and this is across, I've probably talked to 1,000 customers now in a one-on-one setting in the last 4 years. So phase 1 is I moved from physical to virtual, and I did it because my lines of business needed me to move faster. So if I look at a pharmaceutical industry, they can launch a massive pharmaceutical marketing campaign now in weeks as opposed to months. So lines of business would come to IT and say, I need an app up and running and I need it tomorrow. And IT departments would say, give me 3 months, give me 4 months, give me 5 months. Now, those departments are saying, I can get you an application in 1 day, 2 days, self-service, go provision your own. So we have seen across the board the evolution from physical to virtual has absolutely made IT departments move from the department of no to the department of yes. And so we see organizations moving to more and more virtualization because of speed and agility, the ability to provision IT services very quickly. Well, this is the good side. The downside is we've seen a lot of security issues associated with this speed. So let me go through one of them. One of them is around, does anybody remember the MS-12.020? I'm not going to get very technical today, but the vulnerability on Microsoft server and workstation workloads that happened just last month. So basically a hole where anybody can remotely log into your server and take control of it. So these things happen. They happen on all the way up the stack. This is not a criticism of Microsoft. But what we found is in the last few years that patching vulnerabilities is the cause, or not patching vulnerabilities is the cause of 99% of all infections. 99%, right? So somebody asked me the other day if they patched all their vulnerabilities, would they not need AV? And I said, yeah, sure, of course. Nobody's ever patched all their vulnerabilities, right? But what we see is when something like MS-1220 comes out, what happens? The entire operations team stop what they're doing, regardless of what they're working on, and they go work on this. Where am I vulnerable? Where have I not patched? How do I get the patch ready? How do I test to make sure it's going to work in my environment? So as a result, one of two things happens. Either the IT productivity comes to a screeching halt because everybody's focusing on this, or people patch things that are not ready. And we've seen both. As a result, both end in downtime of mission-critical applications quite frequently. How does this relate to cloud? In a highly virtualized environment, this problem is exponentially worse. And let me go through why. So what happens is, before, everybody had physical servers. They knew which critical assets were where. They would start with the critical assets they needed and focus on the most important assets. In a virtualized world, no one knows where those are, right? They also don't know what's coming and going. So we see very commonly virtual machines in the environment will go dormant. Someone will use them for a while. Marketing department comes in, runs a campaign, shuts the infrastructure down, but keeps all the images up. They come in 30 days later, they fire up 100 more virtual machines. Those machines are not patched. They do not have security updates, and they're completely vulnerable inside the perimeter of the data center. So we've seen companies who have reactivated out-of-date security VMs, basically a vulnerable machine inside critical mission architecture and data storage, right? So even in an environment where they're cloning VMs, they may take cloned VMs off an image that's 2 days old and unpatched. So even brand new VMs can be brought up that are unpatched. The reason this is such a big problem is we saw the massive consolidation that most customers went through from physical to virtual, going from maybe 1,000 servers to 200 servers physically. We saw the proliferation of the virtual servers go up to 2,000, 3,000, 4,000. So they used to manage 1,000 servers to patch. Now they're managing 4,000 virtual servers. Those servers are in motion, and those servers are active, inactive, and very dynamic. We have seen a significant impact on operations teams in the ability to secure the virtual infrastructure. So the hypervisor, the infrastructure is very, very secure, some of the most secure infrastructure we've ever seen. The operations side, the people side of this business, as you become highly virtualized, creates security nightmares. Most importantly, operations productivity just goes away. So I'll come back to that. But this is one of the big challenges that seems very simple, just patching. Patching vulnerabilities has become exponentially worse in a highly virtualized environment. Okay, second phase one. Remember, phase one is physical to virtual. In this case, my data center consolidation efforts have increased my security and reduced my company vulnerability. Most people feel that because they've gone from 25 data centers to 5. They've gone from distributed data centers to centralized. And they really look at their checklist around that and say, I think I've covered that. I now have perimeter security around those data centers, and I only have to control 5 instead of 25 items. I'm much more secure. Well, the problem is the nature of threats has changed at the same time. So for a while, many, many years, the antivirus industry was one-to-many for fame. I want to get my name in the paper by bringing down a company. Then we saw the big cyber criminal wave. I want to do it for money. Now, in the last 2 years, we've seen a radical change in terms of advanced or targeted attacks. So now, people are looking to target one-on-one. So as opposed to the old model of one-to-many, we see very, very common attacks, just me attacking one company if I'm a hacker. The reason that's very significant from an architecture perspective is it's absolutely impossible to stop at the edge. So let me give you a good example. We worked with a power company who owned power plants. And they had an APT attack, this was just 3 months ago, where the head of R&D sent one email to 2 people saying we have a quality concern, and it had an infectious PDF. Basically, the PDF had been exploited. One person sending an email to 2 people who both worked for them, titled, "We have a quality concern at our power infrastructure." Obviously, those people opened those emails since it was from their boss. That malware installed on their machines and didn't do anything for 3 months. Just sat there. 3 months later, it reached out to a command and control server, got a new instruction set, and said, I want to look for an Oracle database that has this vulnerability in this environment. Those 2 machines popped up, did a port scan across the environment for about 10 minutes, shut back down, and didn't do anything for another 3 months. This just happened over and over and over again. My point is not to scare you. My point is the nature of the threat has changed. The one-on-one attacks mean that your internal network is as dangerous as your external network, and you must treat it as such from an architecture perspective. So if you really look at how this threat evolves, most of your security is sitting here at the edge of the network. With the advent of Facebook and LinkedIn, most people can get your title and your organization. I think we've all seen this. But that's changed the nature of attack as well because they can do very targeted attacks with a lot more information at their hands. Now, the key is to catch the threat inside the network. So as it looks for targets, as it reaches back out to a command and control server on the internet, that's when you need to catch it. Perimeter security from an outside-in perspective is insufficient in this architecture. Right? So as you move to a highly virtualized cloud architecture, these machines can move. This malware can move at a much faster rate, but getting through the original network infiltration point was quite easy in the age of targeted attacks. So we believe a better way to look at this architecture is to look inside your network for attacks that are happening inside and to notice internal activity. If I had if that power company had vulnerability protection around just their databases, either they would have been patched and not found, or we could have detected it with IPS at the critical asset because we weren't going to detect it at the edge. So that's why the nature of threats, targeted attacks, and APTs, which we have seen a very large proliferation of, particularly around large enterprises and government organizations, has really changed the nature of attack. Once again, it's not completely specific to cloud, but in a highly virtualized environment, the ability to manage and detect that threat needs a change, needs a new architecture. Okay. So the second one we would call inter-VM attacks. So how do you sit inside the data center and make sure that VMs are not attacking each other? Obviously, we haven't seen a whole lot of public DDoS attacks in public cloud infrastructure. We've seen a little bit, but mostly this is for internal organizations trying to sort out whether or not they're the target of a targeted attack. So once again, not any scarier than the old world, just requiring a new architecture. and a new approach. The hackers have been doing what they've been doing for 25 years, right? So my job is not to scare you, just to highlight the difference in architecture and the change and how that needs to be addressed in a new and targeted attack world. Okay, so we actually believe there's a new architecture for cloud. As opposed to outside in, we call it inside out. So we actually believe that data should be built around very small elements. If you're familiar with the NIST organization, they call this deperimeterization. Collapsing that perimeter from physical data center or large area, space and time to very small perimeter. And we really think the best place to focus is on the data and the workload. That way, that data can move to mobile devices, it can move into a virtual infrastructure, it can move into a cloud infrastructure, and the security follows the data. The security follows the workload. So we believe re-architecting from physical edge security to data and workload edge security is the best model for mobility, cloud, and APT targeted attacks. So once again, the architecture and the threat isn't worse, isn't better, just needs a new approach and a new look. So let me kind of go through what we mean by this. Really, our goal is to have all network connected data to be able to defend itself from the attack. That's what we believe is the best architecture for this mobile and virtual and cloud world. Okay, so we believe you can do that a number of ways, and I'll go through an architecture diagram at an enterprise in a few minutes. But modular protection, be able to do data protection, vulnerability shielding, VM isolation, real-time protection, and compliance, all across very small elements of compute and data. Okay, so that was phase one, virtual to physical, or physical to virtual, including the new threats, as well as the new challenges around highly mobile virtualized infrastructure. Now we really look at physical to virtual and whether or not it really has had the business impact. And we get brought in a lot to help IT departments justify to their board or security folks justify to the IT department why their big investment in virtualization is paying off. Well, and we see a little bit of confusion and not necessarily the data we all wanted. So when we look at server CapEx and physical security, absolutely, the cost savings are there. I was able to consolidate 20 data centers to 5, whatever the numbers are, I get my savings. If I look at space, power, and bandwidth, I thought I would get savings. I think I'm getting savings. I'm not completely sure. Partly that scenario where I talked about earlier where someone had 1,000 physical servers down to 500 physical servers, but 4,000 virtual machines. Does that result in less bandwidth? Probably not. Power? Maybe. Space? Certainly. Security operations budget, infrastructure operations budget, and storage CapEx. This is where we all thought we would also see significant savings. And because of some of the problems I talked about earlier, security operations is actually growing. People are saying, wait a minute, I consolidated. Shouldn't I have a consolidated security team? Well, I have 4,000 virtual machines I need to patch. I need more people, right? Infrastructure operations, same thing. I have the complexity of managing stateful tables across routers and firewalls for 4,000 virtual machines. I actually need more people. I don't need less people, right? So that flexibility and that expansion of compute has not necessarily generated savings. Storage CapEx, a lot of people haven't moved to shared storage. Why is that? Usually there's data protection problems. Even in a private cloud, big data Hadoop installation, I can't have R&D data sitting with HR data. So I still have to segment my storage. So even the promise of shared storage in a cloud infrastructure environment, I have not been able to get the cost savings I've had. So we've had to go in with customers to their board to say, this isn't paying off, why not? One of the big things we found out a few years ago was related to security architecture. So let me bring the cost conversation, particularly the question marks, back to how security has negatively impacted virtualized and cloud environment evolution. It's really around resource contention. So what happens? People understand they need to deperimeterize, and they start putting security on every VM. The problem is all of those VMs are now sitting on a shared infrastructure. So now, as opposed to an application having dedicated I/O, dedicated compute, dedicated memory, they're all now shared. So that's the good side. That's what we wanted. We wanted higher utilization. We wanted higher access rates. The problem is I'm now deploying security in every virtual machine across the world. That security, in many instances, is all reaching into that infrastructure at the same time. So we call this the 8 a.m. problem. So let's say it's a VDI environment. Everybody comes to work at 8 a.m. They fire up their desktop. All those desktops go grab security. They update. They go grab IPS update, AV update. They do scanning all at the same time. The entire infrastructure comes coming to a crash. So we really looked at some of the concepts of many, many years ago of how do you pull security off of physical servers and move them to the edge in a different way, in a virtualized environment. So this is not data center edge security, but we do need a little bit better edge security as opposed to deploying security with every VM. So we actually worked very deeply with VMware for years now, probably 3 or 4 years, to say, how do we move security off of each workload and into the hypervisor layer? And so we've been able to define ways jointly on moving IPS, vulnerability shielding, AV, file integrity monitoring for VM environments into a virtual appliance. So now, as opposed to every virtual machine having its own security, you still get host-based security, so you're still at a small perimeter of securing the workload, so the workload can move, but you manage all that at the network or hypervisor layer. So now you don't have all these virtual machines trying to access memory and I/O and storage all at the same time. So this was our way to address organizations' concern that they weren't getting the benefits of cloud and virtualization architecture and evolution. And so we really have moved to an agentless security model that is architected specifically for cloud environments. So what kind of consolidation benefits have we seen? We actually see, this is a good example of probably the average that we see in a VDI environment, for instance. Most people, they deploy traditional AV in a VDI environment and they see 25 hosts per server. As they move to an agentless architecture, we see somewhere of 75 to 100 hosts per server in this case. Oftentimes, we'll see 5 to 10x increase in density. So now, they deployed their virtual environment. They weren't getting the cost savings. They realized security was part of the problem, re-architected security, and now they're getting the density they wanted back. So we're now able to go with customers to say, if you move to this new architecture, you're able to get the benefits of virtualization and cloud computing, not just security. So probably our favorite case study is VMware themselves as a customer. So VMware is doing a BYOD, VDI environment across their organization. I talked about normally the density ratios that people talk about in VDI are between 25 and 100. VMware has achieved 300 desktops per server. So they are achieving 10 times the density on their virtualized infrastructure for a VDI environment because of a new security architecture. So security architecture delivering business benefits, not just security benefits, or what we've been able to work through and why we believe there's a new architecture required for virtualization and cloud. Okay, so lastly, I moved through virtualization and I want to move to public cloud or private cloud in an outsourced environment. Even people that do private cloud, we most often see it outsourced to a service provider. The problem is data. So I moved from performance and cost metrics to data protection and compliance. That's the reason I don't want to move into cloud, right? And it's really around this. I want to use IaaS. I want to use Amazon infrastructure. Well, Amazon tells me that I'm 100% responsible for data protection. If I call my IaaS provider and ask them where my data is at any given point in time, will they tell me? No, they won't. If I ask them where it's been in the last 6 months, will they tell me? No, they won't. They say that's completely your responsibility, but yet you don't have the visibility. So my data, I could be an Australian organization, my data could be sitting in the US, and the US government invokes Patriot Act, and they now have Australian customer data, and I was never even told, right? So it's a huge concern with IaaS, and it's legitimate. Same with SaaS or PaaS. If I use Salesforce.com, I put my customer data in Salesforce. Where is it? Is it secure? Is it sitting shared with my competitors' data? These are the primary concerns we hear. And so we really looked at how do we solve this problem? And once again, it's back down to this deperimeterization. It's securing the data as it's generated and then allowing it to move into public cloud environment, private cloud environment, SaaS environment. And so we actually built an encryption layer in the virtualization architecture that says if you move your data into some cloud, and by the way, is that a bad guy? I think that's a bad guy. All right. So it's sitting in a shared storage environment. This is the problem. The whole benefit of cloud storage and why it's so cheap is because it's multi-tenant shared environment. There is no differentiation between my data and the bad guy's data. How do I know the bad person can't access my data in that shared environment? I don't. So if I encrypt it before it leaves and attach it to my infrastructure, and I keep the keys on my site, I now can move VMs in and out of public cloud, in and out of private cloud, as well as data in and out of private clouds and public clouds. So I now know it's encrypted, I have the keys, it can sit in a shared storage environment, and I know that it's not only compliant, but it's also protected. So we believe that, once again, inside-out architecture, securing the data and then letting it be mobile is the best architecture for cloud environments. So let me bring it all together and close by kind of showing you the evolution of that architecture. We believe security departments and IT departments can stay in control, but yet use and get the benefits of all this cheap, highly available, highly scalable architecture. So this is kind of how we envision this playing out. So I'm in my internal virtual data center. I'm highly virtualized. I'm 60, 70% virtualized. And I want to do some basic security. I want to do vulnerability shielding because my ops people are driving me crazy. I want to only patch every 90 days. I want to be able to build a vulnerability shield around every single machine specific to that application without having my ops teams run around like crazy trying to patch all the time, right? I also want to do IPS and AV around my VMs. So I want my VM to carry security with it. Whenever a VM pops up, I want an IPS profile, I want an antivirus profile automatically assigned to it. And then I want all that hypervisor based because I need the performance as much as possible. So I want to do host-based security on every VM, but I want to put it all at the hypervisor and network layer so I can get maximum density, maximum performance. So that's my data center. I'm pretty much in control. I can control this, but I want maximum performance. Now I start moving workloads into a private cloud. Why would I choose private cloud over public? I have compliance needs. I don't want my data sitting with another customer's data, but I still want to move to a shared storage environment. So in this case, I don't want those departments being able to see each other's data. So even though I'm in shared, I'm nervous that I still need my data protected and encrypted and in silos, at least logically, if not physically. Right? So, but as I start moving workloads into that private cloud to get the advantages of that shared storage, I now want to deploy a different layer of security. I want a little bit more. So I want to add file integrity monitoring from my PCI DSS apps. I need to be compliant. Even though it's my private cloud, I still want to be able to say this data, I know who can access this data, and I know when and where. I also want to encrypt everything. I want to encrypt all data that sits in that environment. I don't necessarily want to do it all here because I want that performance. But as I move to shared storage, I have to. So the ability to just take the same security management, security profile, and just move workloads in and out of virtualized data center into private cloud is exactly what we believe is the right answer architecturally. Now I want to move to public cloud. Whoever the service provider may be, Telstra, whoever's got the public cloud offering for me, I want to take advantage of that massive scalability and availability and the agility of being able to move out there. But now I really need to get serious about security. So I want to deploy a VM out into the public infrastructure, and I want to be able to add agent-based technology. So now I can't hook into the hypervisor. I need to deploy security with every VM. Every VM needs file integrity monitoring. I want to know if that application stack has changed. I want to know if anybody's touched it. And I want to know that that thing is untouched to include whitelisting. I just want to whitelist that application. I want to know if anybody's touched it. And then I want to encrypt the whole cycle. I want to encrypt from VM to data. So I want to know, even before my data hits that shared infrastructure, that VM is secure. So the whole full workload encryption. So the ability to manage the security architecture with an inside-out security model it enables you to be the department of yes. I have a high-performance, secure internal data center. I can allow my departments to move to shared storage, and my lines of business who say, boy, my service provider is willing to give me storage at this price. Can you do that? I can do that. I can move to shared storage. I can move to Hadoop. I can get the benefits of cloud computing, but in a secure internal way. Also, I can now start moving to public cloud in places where I don't have offices around the world, and I don't want to build another data center, or even just using high public-facing application availability. I can move to public cloud all with one architecture and one security. I can deal with APTs, I can deal with mobility, and I can deal with elastic perimeter. So these are our experiences with customers in dealing with their evolution to the cloud and their ability to move their business objectives into reality. We've got thousands of examples. We can certainly bring them to you if you want to talk to. We've got all those business benefits. And Trend Micro, we are the market leader in server, cloud, and virtualization security. And our goal is to help teach you what we've learned, as well as work with you in your environment. Every environment is different, to help you through that journey through the cloud so you get the business benefits and security enables you to go faster and not slower. That's it. Hopefully that was worthwhile to you, and we have more sessions later on today for breakouts on more details. Anyway, thank you very much.